Good morning. I hope everybody's feeling great. Let's get back to some physics. And before we begin, let's get some of the basics out of the way. For example, what is torque? Good morning, Ben. Torque is a twisting or turning force. It can also be a swinging force. You use torque to begin to spin an object or to stop it from spinning. You also can use it to start it swinging or stop it from swinging. Torque relies on the following things. So first of all, you have to have a lever arm. And I know we haven't done a lot of simple machines, but I think in the past, I know you did over at St. Mary's. So let's look at a simple lever that you guys are familiar with. Look down here. Look, there's a teeter-totter. Look, there's John and Ethan having so much fun on the teeter-totter. And right there in the middle is the fulcrum. That's the axis. And then the teeter-totter itself, there is a lever arm. And then on the other side, that would be a different lever arm. And the angle that it makes relative to the horizon or the horizontal, we'll also use the angle of the lever arm. So, like I said, torque relies on a lever arm, a fulcrum, the length of the lever arm. So you only measure from the fulcrum or from the axis, the length of the lever arm until you get to the end of it. And also the sine theta of the angle it makes. So if we looked at this angle right here, we would actually use the sine of that angle in our formula. Let's take a look at torque in everyday life. So hopefully you watched the video I posted. Annie and Emma helped me out on that. And if you haven't looked at it yet, please do that right now. So what formula will we use? Well, we're going to use the funny looking T for torque equals force times the lever arm. Now the formula for lever arm is R sine squared. This is the length or the radius times the sine of the angle it makes. And I know my table seems to be shaking a little bit. We'll try to put a stop to that. All right. So these are the same. What units do you use for torque? Well, since we use force, and force is in newtons, and the length of a lever arm is going to be in meters, so we have the length of, the units for torque are newton meters, and you just write it just like this. So let's try the sample problem together on page 210. So get out your books. Take a look at page 210 and it's the sample problem in the green box at the top. So let's go there now. Sorry guys, I'm having some technical difficulty here. My papers are falling over. All right, let's take a look at the problem. A bolt on a car engine must be tightened with a torque of 35 Newton meters. You use a 25 centimeter long wrench, which automatically, in your minds, you should change that to 0.25 meters. And pull the end of the wrench at an angle of 60 degrees to the handle of the wrench. How long is the lever arm, and how much force must you exert? So we're going to solve two different things. This is the drawing. But let's take a look. First thing we need to write down is, what do we know? Well, we know the formula. This is going to be your formula. Torque equals force times the length of the lever arm, sine of theta. So all of our knowns, we know the radius. They gave it to us in centimeters. I changed it to 0.25 meters. Our angle is 60 degrees, and our torque is 35 Newton meters. So what is unknown? Well, we don't know the length of the lever arm, and we don't know the force. excuse me. We're going to solve for the length of the lever arm first. So we are given the radius of 0.25 meters, but it's at an angle of sine 60. Morning, Emma. So if you just do 0.25 times sine of 60 degrees, make sure that you use your parentheses, you're going to get, for L, is 0.22 meters. So now we can solve for the next portion of the problem, and what is the force? Well, first of all, we have to set it up. So torque is 35 Newton meters equals force times sine of 60. Well, it's actually 0.25. Whoops, I keeps blurring. 0.25 times sine of 60. And we already solved that, and so I'm just putting in 0.22 meters. Well, I want force by itself. So let's divide both sides by 0.22 meters to get force by itself. So now I have 35 Newton meters divided by 0.22 meters. And that's good because we want force to be in newtons, correct? So now our meters will cancel out. That'll leave us newtons. If you multiply this or calculate this on your calculator, you get 159 newtons. The book shows you 160 because they're going to two significant figures. Does that make sense? I'll show you my notes. Whoops. Right there. So if you have to pause and take a look at it, you can. I'm going to move on to the next problem. And we are going to look at number 11 together. So we're going to consider the wrench in example problem 1. We're going to solve for what force is needed if it is applied to the wrench pointing perpendicular to the wrench. Okay, so this is actually telling us perpendicular. That's actually giving us the angle. What angle will you use if something is perpendicular to something else? Well, let's take a look. If we draw something that's perpendicular, you get a right angle. So our angle here is going to be 90 degrees, okay? So we're using the same knowns from the example except the angle. Okay, so everything that was known in the first, sorry, I know my camera skills really suck. Everything that was known to us in the first problem is going to stay the same except for the 60 degrees. We're going to substitute that with 90. So let's plug in our numbers again. So force is equal to torque divided by R sine 90. You're probably thinking, wait a minute, how did she get that equation? Well, I used the original, equation and just flipped it to solve for force. And so here's what I did. If you have torque equals F R sine theta, we can just divide both sides by R sine theta. And this will cancel out. And we're left with force is equal to torque divided by the radius, sine, and the angle. So that's how I came up with this. So now I put in my numbers. And we have the torque is the same. It's 35 Newton meters. This was given in the previous problem. Also given was our length of the wrench, which was 0.25 meters. But now I'm going to use my 90 degree angle, or my perpendicular angle, which is sine of 90. You should get force equals 140 newtons. If you didn't get that, make sure that you are definitely using parentheses, and you might even want to do it in steps. Like do 0.25 times sine of 90, and then do 35 divided by your answer. Okay? So here's what I want you guys to do. For Monday, I want you guys to do numbers 12 and 13. And over the weekend, I'll, of course, make a video that works these things out. And I hope you guys had a nice week. It's beautiful today. So hopefully you get out and enjoy the sunshine. And I will come back to you sometime over the weekend or post this on Monday. Otherwise, I really look forward to your Torque Talk videos. I cannot wait to see those. You guys have a great day. Bye-bye.